The James Webb Space Telescope, humanity's most sophisticated cosmic eye, has recently sent shockwaves through the scientific community with a series of perplexing discoveries made during its mission to peer back into the dawn of time. Perched at the cold, dark Lagrange Point 2, Webb was tasked with unveiling the universe's earliest chapters. However, the signals it has sent back have revealed structures that challenge not only our current models of astrophysics, but our fundamental expectations of the cosmos. For decades, our understanding of cosmic history was built on a foundation of a predictable, steady expansion. But what Webb has found lurking in the deepest, oldest corners of space is not a quiet nursery of infant galaxies. Instead, buried within the dense layers of infrared signals are objects of a scale and maturity that our theories struggle to account for. To appreciate the magnitude of this discovery, let us journey back to an era just a few 100 million years after the Big Bang. According to the standard model of cosmology, this period should be the universe's infancy. We expected Webb to find the cosmic equivalent of toddlers, small proto-galaxies just beginning to coalesce, populated by the first generation of stars. The model is built on this assumption that structures start small and grow over immense spans of time. However, what Webb saw in the cosmic dawn was anything but a nursery. Hidden within clouds of cosmic dust, where no telescope before could see, it found a population of impossibly large, supermassive black holes already fully formed. These weren't just a few million times the mass of our sun. Some were tens of millions, or even larger, already in place when the universe was less than 1 billion years old. This discovery is the scientific equivalent of finding a floor in the blueprints of a construction project that is already built. The timeline does not reconcile with our established models. According to our understanding of physics, there simply should not have been enough time for these black holes to consume enough matter to reach such a colossal size. This isn't one anomalous object that could be dismissed as a statistical fluke. These instruments are finding them repeatedly, suggesting they are a common, yet previously unknown feature of the early universe. The data is clear. The problem, therefore, lies with our understanding, forcing astrophysicists to ask a deeply unsettling question. Is the history of the universe we've so carefully written incomplete? The James Webb Space Telescope has uncovered a secret the universe has been hiding for over 13 billion years. The answer lies in its extraordinary power. Unlike the Hubble Space Telescope, which primarily observes the universe in visible and ultraviolet light, Webb is an infrared observatory. This allows it to see through the dense, obscuring clouds of cosmic gas and dust that shrouded the early universe, clouds that were completely opaque to previous instruments. For decades, this dust was like a veil, hiding the true nature of the cosmic dawn. Webb has finally pulled that veil back. As astronomers processed the data from deep field surveys, the spectrographic analysis revealed something stunning. They found the telltale signatures of massive black holes actively pulling in matter. These signatures, visible only to Webb's sensitive instruments, showed hot, highly ionized gas swirling at incredible speeds, the unmistakable fingerprint of a black hole's accretion disk. One of these objects, located in a galaxy called CS7, was found to have a mass 50 million times that of our Sun, existing just 740 million years after the Big Bang. This discovery left scientists scrambling for an explanation. One leading theory was that these black holes grew through a process of cosmic cannibalism where black holes collide and combine. Indeed, Webb provided a crucial piece of evidence to support this model. In that same system, CS7, Webb captured the earliest, most distant black hole merger ever witnessed. This was a landmark discovery in its own right, confirming that mergers were an important route for black hole growth at cosmic dawn. But even this violent, rapid process might not be enough. The model still struggled to explain the sheer number and size of these objects. The mergers would have to occur with an almost impossible frequency and efficiency. A significant gap in our understanding remains. As the scientific community grapples with this improbable timeline, a more radical realization is beginning to set in. The challenge posed by Webb's data is so profound that it may require a fundamental reshaping of our entire cosmological model. The first implication is a complete inversion of our theory of galaxy formation. The traditional model has always been that a galaxy comes first. A vast cloud of gas collapses to form billions of stars, and only then, over eons, does a supermassive black hole gradually form at its center. But these discoveries suggest the opposite may be true. What if the massive black hole forms first, acting as a gravitational seed or scaffold around which the entire galaxy then assembles? In this scenario, the black hole isn't born from the galaxy. The black hole builds the galaxy around it. This has led to renewed interest in the heavy seed hypothesis. Instead of black holes starting small from the remnants of stars, this theory posits that, under the unique conditions of the early universe, a vast cloud of primordial gas could have collapsed directly into a black hole of immense size, bypassing the star formation phase entirely. This direct collapse could create a black hole tens or even hundreds of thousands of times the mass of the Sun in a single event. While this theory helps with the timeline, it opens a Pandora's box of new physical challenges, as such massive clouds are theoretically expected to fragment into stars, not a single monolithic object. When a discovery is made, it is so profoundly at odds with established theory, its effects ripple outwards. If our models for the ancient universe are this incomplete, what else have we gotten wrong? The James Webb Space Telescope seems determined to make us ask that question over and over. For example, its recent observations of the Orion Nebula, a stellar nursery just 1,350 light-years from Earth, have uncovered objects that have left scientists utterly baffled. They are called Jupiter mass binary objects, or jumbos. These are pairs of planet-sized objects, each with a mass comparable to Jupiter, that are orbiting each other without a parent star. According to our leading theories of star and planet formation, these objects simply should not exist. Planets are supposed to form from the disk of material orbiting a star. While rogue planets are thought to be ejected from their home systems, that violent process should tear a binary pair apart. Yet, Webb has found dozens of these pairs, suggesting they are a common but completely unexplained outcome of stellar formation. As one ESA scientist involved in the research stated, there's something wrong with either our understanding of planet formation, star formation, or both. This is the recurring theme of the James Webb era. We are in an age of profound new questions. The discovery of these anomalies has opened the door to even more radical and, frankly, more unsettling speculation. When current models fail, scientists are forced to consider ideas that were once on the fringes. One of the cornerstones of modern cosmology is the cosmological principle, which states that, on a large enough scale, the universe is isotropic. It looks the same in all directions. There should be no preferred orientation, no cosmic up or down. The number of galaxies spinning clockwise, for instance, should be roughly equal to the number spinning counterclockwise. However, a recent study of 263 distant galaxies observed by Webb found a shocking pattern. Roughly 2/3 of them appear to be spinning in the same direction. This observation, if confirmed, would represent a profound violation of the cosmological principle. How could this be? One potential explanation is that the universe itself has an overall spin, an angular momentum inherited from the moment of its creation. One of the few cosmological models that predict such a spin is the speculative theory that our universe was born from the collapse of a star in a higher dimensional universe. In such a scenario, the event that created our universe also created a black hole, and our cosmos is what lies on the inside of its event horizon. This idea remains highly theoretical and far from mainstream consensus. But the fact that Webb's data is forcing such possibilities to be discussed, even at the periphery, shows the magnitude of the challenge we now face. The impossibly large black holes Webb is finding might not be anomalies. They may be echoes of a cosmic structure far stranger than we ever imagined. We began this journey with a series of objects that shouldn't exist, black holes from the dawn of time that are too big, too soon. But the investigation into their existence has led us to question the very foundations of our cosmic models. From the way galaxies are born to the laws governing the formation of planetary objects, and even to the symmetry of the universe itself, the James Webb Space Telescope was built to be an answer-finding machine. Instead, it has become a question-generating machine of unparalleled power. It has demonstrated that the universe is not just more complex than we know. It is more mysterious than we have ever dared to imagine. The door to the early universe has been thrown open, and what we are finding on the other side is not the neat, orderly cosmos of our textbooks. It is a place filled with structures that defy our logic, forcing us to reconsider our place within reality itself. The search for answers has only just begun.